In this short video tutorial, we will look at the voltage against current characteristics for three common components in electrical circuits. I'm going to start off with the resistor. So if I draw some axes, in this instance I'm going to plot current on the x-axis, voltage on the y-axis. A resistor has a nice straight line going through the origin, showing that voltage is proportional to current. So we can say voltage is proportional to current. We would call this an ohmic component because it's obeying Ohm's law, where the voltage and current increase proportionally. Nice and simple. And in this instance, the gradient of that would be equal to the resistance. In other words, a higher value of resistance would result in a steeper gradient. Okay, so this is a higher value of resistance, and a lower value of resistance would result in a shallower gradient. So that's a resistor. Moving on to a light bulb, in the same way, if we plot voltage against current, what happens in the case of a light bulb is when you first turn it on, the resistance is actually lower than once it's heated up a bit. The tungsten filament in a standard light bulb has a tendency to increase its resistance as you increase the temperature. So what we actually end up with is a curve looking something like that. Okay, starting off at the origin but then increasing its gradient as it goes up. And in this case you need to be careful. The resistance does not equal the gradient. You would simply divide voltage by current to find it at any point. Moving on to the case of a diode. A diode is a semiconductor, and that does something a little bit different. Again, we start at the origin. Now, in reverse bias, that is to say when we have negative voltage, I'm just going to draw below the axis here. If we were to draw the line here, we'd basically get no current at any voltage. Okay. One of the good things about a diode is it only allows current through in one direction. In the forward bias, so connected the correct way in the circuit, what we find is that it has a reasonably high resistance. It's quite steep at first, until it reaches a point when it starts conducting a great deal and its resistance jumps down and it allows much more current through after a certain point. So we have a point here, okay, at which it kind of turns on, sometimes called the strike voltage or turn on voltage or knee voltage even. And this is a point after which it conducts with a much lower resistance. So we can see that that's distinct from the light bulb, curves in the opposite direction. Both the light bulb and the diode are non-ohmic conductors. So in both of these cases, we would say they are non-ohmic. They don't obey Ohm's law. They don't have voltage proportional to the current.